In this lesson, we'll introduce the concepts and practices of version control and how to use the version control system Subversion. Let's first use an example to motivate the needs for version control. Suppose I'm a software developer and I want to write some software and make some money. This is what software development usually looks like. I start writing some code, produce a prototype. I keep working on it until the software is ready to be released. Then I release the software, make some money, and continue to work on the software to fix bugs, to add new features until the next version is ready. And we can keep going like this. In a perfect world, this process is linear in the sense that we always go forward and never need to go back. Unfortunately, in the real world, it doesn't work like that. For example, suppose at this point, between the prototype and the first release, we added a new feature that completely broke existing code. Something like this probably had happened to all of us. Usually it's right before a homework is due, we want to just make one final change, but all of a sudden the whole program stopped working and we're in a panic. The homework is due in 2 minutes. All we want to do is undo the changes and submit the previous version to get at least partial credit. But how can we find out which part of the code has been changed? And how can we revert to the previous version quickly? Well, as most of us know, without version control, it can be pretty difficult. Now, let's say we survived all that. We fixed the problems and actually released our first version. We'll be happily working towards our next version while a customer comes to us and requests a new feature or a bug fix. Note that we now have two versions of the code. The version we are currently working on, which we'll call the development version, and the version that was released, which we'll call it version 1.0. Now the question is, which version do we use to meet customer 1's request? Version 1.0 or the development version? The answer is, of course, version 1.0. Development version is called development version for a reason. It may have more features, but certainly more bugs as well, and we can't send our customer code that hasn't been rigorously tested. So if we find version 1.0, hopefully we have kept it around somewhere, putting the feature or the bug fix customer 1 requested and send it back to customer 1. So far so good, except that now we have 3 different versions of the code. We have version 1.0, version 1.0 plus customer 1's changes, and then the development version. What if another customer comes to us and asks for their feature or bug fix? Which version do we use to meet customer 2's request? Well, development version is out of the question for sure, so it's either version 1.0 or version 1.0 with customer 1's changes. So which version to choose typically depends on the situation. If both customers' requests are relatively minor and the code won't interfere with each other, you can use version 1.0 with customer. You can use version 1.0 with customer 1's changes. However, it's also possible that the customer 1's code may interfere with customer 2's code. For example, maybe customer 1 wants you to optimize the software for mobile devices, while customer 2 wants you to optimize it for servers. Another common scenario is both requests come at about the same time, and you want to complete them quickly, so you assign them to different developers so they can work on the request in parallel. All in all, there's a fair chance that you have to put customer 2's code in version 1.0 which leads to yet another version to keep around. And you'll keep going and going, and if your software is popular, you'll end up accumulating lots of different versions. At some point, you'll say enough is enough. Instead of waiting for version 2.0, I'm going to release an intermediate version 1.1. This version will include all the bug fixes and some minor features we have implemented so far. Now the problem is that all those bug fixes and changes are scattered around in many different versions. How do you collect them into one version? Well, you can certainly do it by hand, but it's going to be very tedious and error-prone. By now, you can probably see that even for fairly straightforward software development with a small team or even just a single developer, there's great need for tools that keep track of versions and changes. So it comes as no surprise that there are lots of software tools developed for that purpose, and this type of software tools are called version control systems. CVS used to be the most widely used open source version control system. By the way, CVS stands for Concurrent Version System. It's not the drugstore CVS. CVS has been superseded by Subversion due to various problems. And Subversion is the version control system that we'll use today. There are also many other version control systems, both open source and commercial. Many of you probably have heard of Git, Visual Source Safe, and so on. Git in particular is a very popular version control system these days. By the way, if you Google BitKeeper controversy, you'll find an interesting backstory of how Git was originally started. These days, Git is undoubtedly the most popular open source version control system, widely used by both open source projects and commercial companies. The reason I decided to use Subversion instead of Git in this class is simply because Subversion is more beginner friendly. In Subversion, there's only one type of repository, but in Git there are two, and that complicates things quite a bit. Also, Subversion has much better integration with Eclipse GUI, so you can pretty much do anything without using command line. Because most people in the class never used version control before, I think it's better to use Subversion to introduce the basic concepts. And once you are familiar with the basics, it's a lot easier to learn other version control systems like Git. Excuse me. Here's the basic command syntax of Subversion. Most Subversion commands takes one or two URLs, and a URL can represent either a local path or a remote location. Now let's see the first operation, import. Import takes an unmanaged project and put it into a so-called repository. A repository is basically where a version control system keeps all the different versions of a project. At the beginning of the class, each of you have received a CS3 account, and each CS3 account comes with a Subversion repository. I have the account CS520STU31, so I'll use the repository for that account. On the CS3 server information page, if you go down to the Subversion section, you can see that the Subversion repository URL has this form: svncs3.custody.la.edu, course, quarter, and then username. The course is CS520. This quarter is summer 2015. And so the quarter is X15. It's X15, not a full quarter name. And my username is CS520STO31. So in Eclipse, go to SVN repository exploring perspective, we can add that repository to Eclipse. It's svncs3.custodela.edu, and then its course quarter username. Course is CS520, quarter is X15, that username is 520STU31, and that's it. As we can see, now currently this repository is empty, and we'll import a project into it. The project I'm going to use is this MVN example project that we have seen in the Maven lecture. As we can see, it's a very simple Maven project, and it only has two files, a pom.xml file and a Java class hello.java. And is organized in a typical Maven project directory structure, source main, Java, and so on. Only two files. Now let's import this project into our repository. But before we do that, we want to reorganize the project directory structure a little bit. In particular, under the project, we are going to create three folders: trunk, branches, and tags. And then we move all the files and the directories that are previously directly under the project folder to the trunk folder. So it looks something like this. We'll create three folders: trunk, branches, and then tags. And we'll move the previous file and the folder that are previously under the project folder to the trunk folder. So after reorganizing the directory structure, you can see it now looks like this. We have an empty tags folder, empty branches folder, and then under the trunk folder is actually our project. Now, this is something specific to Subversion. If you use a different version control system, it's likely that you won't need to do this. But Subversion, because of the way it implements branch and tag operations, this is typically how a Subversion repository will look like. In a moment, once we discuss tags and branch operations, you'll see why the directory is organized like this. Okay, so now our project is ready to be imported, and let's import that. So the command to import the project is svn import, of course, and then just like most svn commands, it takes a source URL and then a target URL. The source URL is a local folder, which is this one, which is basically the project folder we want to import, and the target URL is the repository location where we want to import this project to. So it's cs3.custodela.edu cs520 x15 my computer just froze. Okay, x15 cs520 stu31/mvn example. So this command basically says import this local folder to this remote folder, basically. And also it requires a log message, basically describe or add some comments to this operation. We'll say this is initial import, and I'll say my password, and that's it. So now this project is imported, and to verify that, we can come back to here, do a refresh, and we can see that now we have our project in the repository. Both branches and the text folders are empty, and in their trunk we have our project, which is great. Now, once a project is imported, we can discard it, but instead of doing that, we'll keep this project for now, and later on we'll compare this to the copy that we check out from the repository and see what's the difference. So we're going to move it to a separate folder called mv_example.original. Okay. So this is the import operation. Basically takes a unmanaged copy of a project and put it into a repository. Now the second operation is kind of the opposite of import. Now we want to take out a copy of the project from the repository and put it on our local computer so we can work on it. This local copy is usually called a working copy or a version controlled copy. So let's see how we do that. As you would expect, the command for checking out a copy would be called checkout. So we say svn checkout, and again, the source URL and the target URL. And this time, the source URL would be something like this, and the target URL would be something like this. We want to check out from this remote location and put it at this local location. Now, if we do this, we would be making a very common beginner's mistake. And that mistake is to check out the whole repository. But notice that if you look at the whole repository, this is the whole repository. It contains not only the project, but also some seemingly unnecessary folders like branches and tags and so on, right? So the proper way to check out a project is not to check out the whole repository, which may contain many different copies or versions of the project. We want to check out from the repository just the version we want. And right now, the version we want is under trunk. So the right URL for source URL is actually trunk. In other words, keep in mind that you don't want to check out the whole repository. You want to check out the version in the repository that you want to develop on or work on. And right now, that version is under the trunk folder. So check out trunk, not the whole repository. So now you can see that we have checked out our version. And it has POM, it has source, and under source it has our hello class. And if you look at this, it looks like a normal project folder, and nothing seems to be different or interesting. Before we see the different and interesting part, let's do the checkout on the GUI side as well. So on the GUI side, again, we check out the trunk folder. Remember, don't check out the whole thing. So right click on trunk and select checkout as a Maven project, and that's it. Because our project is a Maven project, the pom.xml file is a full description of the project. So there's no other configuration necessary, and everything should be taken care of. And we can see the we can see the project here. Okay, so now we have checked out a working copy or version control copy, and you may be wondering that what's the difference between this version working copy and the copy that we imported into the repository. Well, let's see. Okay, I just made some changes to the pom.xml file, and if you didn't pay attention, you probably have missed what changes I have made. And remember our example at the beginning, like this, right? We just made some changes, and now the changes have broken some existing code, and we want to find out what changes we have made, and maybe we want to change it back or something. And without version control, it's difficult, especially if the changes are scattered around in different files, and especially if those files are complex or large. But now with version control system, we can do svn status. Well, notice that the svn status tells us that this pom.xml file has been changed. There's an m label here, and m means modified. So svn status is a command that tells us which files have been modified or changed or added or deleted. And here it says this file is changed. Well, what are the changes? We can use svndiff to see the changes we just made, and svndiff tells us that for this file pom.xml, we have removed one line. Notice the minus sign here, and added another line. So if you compare these two lines, you can see that the changes we made was to change CS520 to CS521. Pretty clear, right? Okay, so if you say, this is a mistake, I don't want to make these changes, and we can do a svn revert. We'll revert this file, and now if we do a svn status, nothing is shown. svndiff, nothing is shown. If we look at this file again, it says CS520 again. We have reverted the change. So now you can see this working copy or version controlled copy is indeed different from the copy that we imported to the repository. So somehow this version control system remembers all the changes we have made, and it can show us the changes, and it can help us to reverse those changes if necessary. So what's going on here? Well, if we take a closer look at this folder, you can see that in addition to our project files, which are basically these ones, it also has a hidden folder called .svn, and under that hidden folder there are a bunch of other files, and this is where Subversion performs all the magic. So when you check out a working copy from a repository, it's not just your project files. The version control system will also create a bunch of files that it used to keep track of all the changes and all the versions for your project. For Subversion, those files are stored under a hidden folder called .svn. And by using those files, version control system can keep track of your changes, keep track of your versions, and help you to perform lots of different operations. Now, in a GUI, it's the same thing, except that it's even easier, or simpler. For example, if we make a change to this hello.java, notice that now there's a sign there that indicates that this file has been changed. And if you want to know what are the changes, right-click on the file, select Compare With, and then select Compare With Base Version. Base revision is the original version that you just checked out from the repository. And you can see that the repository file has hello maven, and the changed file has hello maven plus empty space at the end. That empty space is actually highlighted here, so it's pretty easy to see. Right? In other words, you don't even need to do svn status to see which files has been changed, and you can use compare with to do the same thing as svn diff. And similarly, if you want to revert the change, go to right-click on the file, go to team, and revert, and then you can revert the change. By the way, most version control operations are under the team menu, and the comparison functions are under compare with menu. So these two menus are mostly related to version control operations. Okay, so this is the checkout operation. The key thing to understand here is that when you check out a copy from the repository, it's a version controlled copy. It's not your original project anymore. With some additional files, the version control system is now capable of tracking the changes happened in your project. Now, let's make some changes and then save it back to the repository. And that operation is called commit. So let's say, since we are talking about version control and subversion, so instead of saying hello maven, let's change it to hello subversion. And we can see that this file has been changed. We can do compare with to see what the change is. And then we can, well, before we commit anything, let's add a new class. I'm going to add a new class called hello2. Okay, so suppose I make a change to the hello class and add a hello2 class, and now I want to save those changes back to the repository, and that, as I mentioned, is called commit. So to commit, we right-click on the project, select team, and then select commit. And this is the GUI for commit in Eclipse. Note that the files it's about to commit or save back to the repository includes not only the changed files, but also the files in the project that are currently not under version control. In particular, it includes a bunch of files created by Eclipse to manage the project. Because we use Maven to manage our project, we don't need these Eclipse project files. So what you can do is you can uncheck those files before you commit. Another way to do that is to uncheck this option, show unversioned files. If you uncheck this file, it will not try to commit those unversioned files in the project. But the problem with this is that if you uncheck this option, notice that hello2.java is gone as well, and we actually want to commit this file. So you can either manually uncheck a bunch of files or do something like this. I usually want to manually add my new files to version control by doing right click, team, and then add to version control. So by doing that, now I have both files under version control, and when I do a commit, now I can simply uncheck this option so that it won't try to commit all the other files, only the ones that I specifically add to the version control. So for commit, the second thing I want to mention is this commit comment. So for each repository operation, you are supposed to put in some comments to describe that operation that you perform. And if you use Eclipse, Eclipse actually allows you to leave this empty, but this is a bad practice. You should always put some meaningful comments here that describe what changes you have made. And these comments are an important part of your project documentation. So before I click OK to commit, I would describe what changes I have made, and I'll say with a changed Maven to Subversion, added another class, something like this. And then I can click OK, and that commits the changes to the repository. Notice that after commit, those signs or icons about the changed files are gone, which basically means that now our local version is in sync with the repository version. And if we go to the repository and refresh, where is refresh? Here. We can see that now we have 2 Java files here. For commit, it's important to understand that it doesn't overwrite the old version. The repository keeps all versions of each file, so you can always go back to a previous version. And this is an important function of version control systems. So don't worry about overwriting old versions. The opposite operation of commit is update, which is the operation to pull changes out of a repository and apply them to the working copy. So if you look at this side, you can see that in this copy of the project, we still only have one class called hello.java. And if we look at that class, we can see that it still says hello Maven. So how do we get the changes from the repository and apply them to this copy? Well, it's pretty simple. We can do a svn update, and this operation will pull the changes from the repository. And after updating, you can see that again it shows a couple of labels here for the updated files, and the U label means updated, and that of course means hello.java is updated, and the A label means added. It means that hello2.java is a new file. And if we look at the files again, we can see that hello2.java is here, and if we check the content of hello.java, we can see that now it says hello Subversion instead of hello Maven. So basically the update operation, and we can do update operation in GUI as well. This is simply right click on the project, select team, select update to head. Head is the name for most recent version in repository. So if we do update to head, it basically does nothing because this working copy is already the same as the most recent version, the latest version in repository. So in this case, update doesn't do anything. But if there are new changes in the repository, that's not in this version, update to head would pull those changes. Okay, here's a quick recap of the 4 basic operations. Import and check are kind of a pair, which get a whole project in and out of a repository, and commit and update are kind of a pair, which get changes in and out of a repository. There are 3 more commonly used version control operations: tag, branch, and merge. Tagging is to assign a name to a certain state of the repository. For example, let's say after 3 revisions of file A, 5 revisions of file B, 4 revisions of file C, and 6 revisions of file D, we are finally ready to release version 1.0 of our software. It makes lots of sense to create a tag at this point, so that we can easily go back to this state later on. Different version control systems implement the tag operation in different ways. In Subversion, the tag operation is actually implemented using a copy operation. And with this implementation, tagging in Subversion takes constant time regardless of the size of the project. To create a tag, we simply make a copy of the project and place it under the tags folder. And this is, by the way, why we created the tags folder when we import the project into the repository. So suppose now for our Maven example project, we are ready to release version 1.0, and we want to create a tag. Like I said, a tagging in Subversion is basically a copy operation, and we want to copy the current version under trunk and make a copy of it under tags. So right click on trunk and then select branch/tag. By the way, when you right click on trunk, you are essentially telling Subversion that trunk is the source URL or the source folder. And then Subversion will ask you to specify the copy to URL. And we want to create a tag, so we copy it to somewhere under tags, and we'll say make a copy to tags under the folder version 1.0. And head revision, that's the latest. And again, give a comment here. We'll say tag release version 1.0 and finish. So now as we can see, we now have 2 copies of our project. One is a tag 1.0 under tags folder, and the other one is under trunk folder. Okay, so if we look at our previous example, we are kind of at this point, right? We have completed our version 1.0, we have released it, and we have made a tag just in case we need to go back to it. Great. And let's say we continue. We make some additional changes and work toward release 2.0. So let me go back and let's change this to, for example, working toward 2.0. And let's commit this to the repository. Continue development toward 2.0. Okay. Now notice that after the commit, if we look at here, we can see that this change has been committed to the trunk folder, and also notice that it does not affect this version under tags version 1.0. The reason being that notice that for a project, the version control system remembers where that project is checked out from, and it actually tells us here that this one is checked out from VN example trunk. So when you commit, it commits back to wherever it comes from, and it won't affect any other versions. Okay, going back to our example, now let's say that, okay, we are now at here, and a customer comes to us and requests some changes. As we discussed before, the right way to do this is to make the changes on version 1.0 instead of on the development version. So you would think that what we would do is check out this version, make some changes, and then commit it back, right? Well, wrong. That's a very common beginner's mistake. It's wrong because notice that once you commit the changes back to the repository, now the tag version 1.0 is no longer the real version 1.0. It would become 1.0 with customer 1's changes. Most version control systems will not even allow you to commit back to a tag. But because of the way Subversion implements tagging, you can actually commit back to a tag. But we know that conceptually it's the wrong thing to do. So what is the right thing to do then? Well, the right thing to do is to create a branch. In Subversion, the branch operation in Subversion, the branch operation is also implemented as a copy operation. So in that sense, it's very similar to tag. But conceptually, it's quite different in the sense that creating a branch allows you to work on different versions of your project in parallel, and you can commit back to a branch, unlike a tag, which are not supposed to be changed. So to meet customer 1's request, what we'll do is we'll create a new branch based on the version 1.0 tag, something like this. We'll right-click on version 1.0, we'll select branch, and the target or copy to URL would be branches v1-c1, which stands for version 1 for customer 1. And we'll say pull a branch for customer 1. And now we have a new copy here. And again, you can see why we created a branches folder at the beginning. And this is basically the Subversion's way of managing branches. And with this, instead of checking out version 1.0, we'll check out this one and make changes to it. So we'll say right click, check out as Maven project, and OK. Now, normally we'll check out a Maven project, you wouldn't need to do anything extra. But because we already checked out a Maven project that has the same project name, now if we don't do anything, there would be a project name conflict. So what we need to do is we need to give this a suffix. So artifact ID, remember, is a project name. So checking out this one, we'll call it artifact ID v1-c1, and click on this and then finish. Okay, now you see that we have a new copy of the project, and this is a copy that's based on version 1.0, and this is the copy that we can use to make changes requested by customer 1. So let's say customer 1 wants us to print out hello customer 1. And we commit the changes back. Customer 1's changes. Okay. So that handles this. And let's do the same for customer number 2. So suppose we have another customer that wants some changes, and we'll make a branch for that customer. We'll say branches v1c2 to a branch for customer number 2. And we check out this one. We give it a name. And this one, let's say customer number 2 wants us to say hello customer 2. So again, commit the change, commit the meet customer 2's changes. Okay, so that solves our problem here. And then let's suppose that now we are at this point where we want to create an intermediate release 1.1. We want to collect all the changes we made so far into this release, and of course we don't want to do manual copy and paste. So how can we do this? Well, this is where we can take advantage of the merge operation. The merge operation will help us to copy changes between branches, basically. And let's see how we can do that. So first, we want to create a branch that we will use to collect all the changes. And that branch originally is based on 1.0. So we'll create a branch, and we'll say this is version 1.1-dev, which means this is the development version for 1.1 release. A branch for 1.1 release. And let's check out this version. Again, it's 1.1 def. Okay, here it is. Notice that this version currently is based on 1.0. So we have made some changes, and those changes are in the v1-c1 branch and the v1-c2 branch. So of course, what we want to do now is to copy those changes to our new 1.1 development branch. Just like before, when you try to do operation in Subversion, you would need to provide a source URL and a target URL. And if you think in terms of copying changes from one branch to another, you would think that we would want to copy changes from v1c1 to v1.1 def, and from v1c2 to v1.1 def, and so on. So when you do merge, you would think that the source URL is v1c1 and the target URL is v1.1 def. But unfortunately, in Subversion, the semantics of the merge operation is a little bit odd. What it says is this: the merge operation between the source URL and the target URL compares the version of the project represented by the source URL and the version represented by the target URL, calculate the changes needed to transform the source version to the target version, and apply these changes to the working copy. So it's not very intuitive to understand. First of all, understand that there are three things involved here: the source, the target, and the working copy. So source and target, you can think of those as versions inside the repository. And so what Subversion does is it compares the difference between the source and the target and applies those differences or the changes to the working copy or your local copy. And in particular, the changes are the changes needed to transform source into target. So it's kind of the opposite of what you would think in terms of copying changes. When you think of copying changes, you would think copying changes from source to target. But here is kind of the opposite. It's transforming source into target. So in other words, the changes are actually in the target part. The source are the ones that is the one that does not have the change. Now, once you understand this, admittedly not very intuitive to understand, but once you understand this, it becomes pretty easy to use. So the first thing we want to do is we want to copy the changes in v1c1 to version 1.1 def. So what we do is we right-click on version 1.1 def and do a merge, right? So for merge, we need a source URL and a target URL. And what's the source? What's the target? Well, the source is version 1.0, and the target is this. And in both cases, we want the latest version in the respective branches. Now, if you don't immediately see why, think about this a little bit and read the semantics of Subversion merge here and understand. So what we are doing here is essentially that we are taking the difference between this branch and the original 1.0 and apply that difference to our working copy. That's exactly what we want to do, right? And the only kind of difficult part to understand is why the source is 1.0 and the target is this, and that has to do with the semantics of merge in Subversion. In any case, so this is what we are going to do, and we take the difference between these two and apply it to the local copy, and that is our merge. And after merging, you can see that the changes are now automatically applied here, and you can see it's now saying hello customer 1, and hello2.java is modified. And so far so good. We commit the changes back to the repository, and we say merged changes from v1 c1. And we'll do the same thing for the changes in the v1 c2 branch. So we do another merge, and this time the source is still 1.0, but the target now is v1 c2, and we merge. Now, the merge worked, except there's now a problem. The problem is customer 1 wants us to print out hello customer 1, and the customer 2 wants us to print out hello customer 2. And they both change the same location in the same file, and now we have a so-called merge conflict. Merge conflict is not that uncommon, and when you first see a bunch of error signs like this, it may be somewhat unsettling, but I'm saying that this is pretty common in terms of merging, because after all, there's really no guarantee that there won't be any conflicting changes to a file whatsoever. So this is not uncommon. So there are various ways to resolve this. If you right-click on the file that has a merge conflict and look under team and look under mark resolved, you'll see a bunch of options. And the options below here are basically ways to automatically merge, automatically resolve the conflicts based on, for example, whether you want to choose customer 1's version or customer 2's version, and so on. And in this case, we can also manually change the code. So for example, we don't want to keep either customer 1's version or customer 2's version, and instead we want to change this code so that it addresses both customer 1's and customer 2's problem. So it will say hello customer 1 and 2. And after we've done that, this code is now working, but before we can do anything else, we have to tell the version control system that this merge conflict has been resolved. So right-click on the file and select. Before we do that, notice that the version control system will automatically create a few additional files that tells you what the code looks like before the merge, after the merge, and so on. So right-click on the file, select team, and select mark resolved, and select the first options that says conflicts has been resolved in the file, which is exactly what we did here. So select that and say OK. And notice that all those additional files has been have been automatically removed, and now we have this normal modified icon here indicating that this file has been modified. And after resolving the conflict, we can now commit the code back to the repository, and we say merge changes from v1 c2. Okay, so we only have 2 versions here, but you can imagine that if you have more, you can just keep doing this to collect the changes from all the previous versions, and until version 1.1 is ready, and then what we do is we can release that, and before doing that, we of course create a tag. So this time the tag is based on version 1.1 dev. So right click on that and then select branch/tag, and now we want to tag this one to be version 1.1. And we'll say tag release version 1.1. Okay, so that's pretty much it. Today we covered 7 most commonly used version control operations: import, checkout, commit, update, tag, branch, and merge. To learn more about Subversion, please check out the Subversion book here. The Subversion book is very good, but it covers only command line syntax. If you want to know how to use the Eclipse plugin Subclipse to do import and merge, please check out my write-up here. Thank you.